Testing procedure: physical and mechanical tests. The probe or access, impact, and stability tests are designed to determine if the construction of a piece of equipment and the physical attributes of its enclosure are safe under normal use and when subjected to various forms of abuse. Safety precautions. Follow all normal laboratory safety precautions during these tests. The EUT should not be energized during the tests. The stability test can present challenges, especially for heavy equipment that could topple and potentially crush a person or cause irreparable damage to the equipment. Care shall be taken to prevent potential hazards during the test. Test apparatus. Depending on the test to perform, you will need test fingers for probe or access tests, steel ball, 50 millimeters diameter and a mass of 500 grams, or as specified in Part 2 standard, and a 2-inch ABS plastic pipe or lightweight cord. Example, a 15-pound test fishing line. 10-degree incline jig or inclinometer for the stability test. There are several apps available on your cell phone that are adequate to use as an inclinometer. The Clinometer app by Planecode and Compass by Apple have been verified to be accurate by ESAFE with a calibrated inclinometer. Before using a different app, please contact the technical manager to have the app verified and validated. Care of mechanical testers. Probes and impact balls must be stored properly to avoid damage to the outer surfaces. If they start to show signs of damage or wear, or if they become defective, the equipment must be tagged and processed as per FE APM number 23 procedure. Probe test. A sample consisting of the complete enclosure or a portion representing the largest non-reinforced area should be supported in its normal position. Ensure all user or operator accessible covers are removed. Test setup and procedure. Verify that the instruments are in good working order and do not show any signs of damage or wear. Insert the probe or probes into openings of the enclosure without appreciable force. Openings in an enclosure are acceptable when the smaller dimension of an opening does not exceed 12.7 millimeters and a probe of the dimension shown in Figure 1 cannot be made to touch live parts when inserted through the opening point first. Openings in the enclosure of handheld products are acceptable if a probe of the dimensions shown in Figure 2, when inserted point first as far as possible into the opening, does not enter the opening for a distance greater than 3.2 millimeters or touch any bare live part. Openings larger than permitted may be accepted provided that the distance between the edge of the opening and the live part is at least 6 times the smaller dimension of the opening, but in no case less than 101 millimeters. Impact test. Verify that instruments, impact ball, pipe, or string are in good working order and do not show any signs of damage or wear. Test setup and procedure. The pendulum swing impact test. This test should be conducted using a solid smooth steel sphere with a diameter of 50 millimeters and a mass of 500 grams. A 1.3 meter long lightweight cord to hold the mass of the sphere and a metal clamp to act as a pivot. Select an appropriate part of a specimen where the impact test can take place. Once an area of impact is determined, the specimen can be placed firmly on a smooth horizontal surface. The metal clamp is placed at a vertical height of 1.3 meters from the desired area of impact. The cord must be 1.3 meters in length and connected to the clamp on one end and the sphere on the other end. The sphere can then be moved away from the clamp, which acts as a pivot point, and swung towards the desired area of impact. As soon as the sphere makes the initial hit, the cord is refrained from allowing the sphere to make rebounding hits. The vertical impact test. When the pendulum test is inconvenient, horizontal impacts on vertical or sloping surfaces may be simulated by positioning the sample so that the surface to be impacted is horizontal and applying the vertical impact test instead. This test should be conducted using a solid, smooth steel sphere with a diameter of 50 millimeters and a mass of 500 grams, along with a hollow plastic pipe at least 1.3 meters in height and having an inner diameter of 50 millimeters. Select an appropriate part of the specimen where the impact test will take place. Once an area of impact is determined, the specimen is placed firmly on a smooth, horizontal surface. The hollow plastic pipe, sized to let the ball pass through, is placed vertically on top of the desired area of impact. The sphere is placed inside the pipe, right at the marking of 1.3 meters. The sphere is then dropped at the area of impact. As soon as the sphere makes the initial hit, the pipe is moved to avoid rebounding hits. Acceptance criteria. The enclosure shall withstand an impact of 6.8 joule without loss of integrity such as to permit access to hazardous parts or water or dust ingress, where applicable, or interfere with the operation of safety devices such as thermal cutouts, overcurrent protection, or interlocks. In addition, after the tests, the sample shall comply with the requirements for protection in operator access areas, grounding and bonding, spacings and distances through insulation, cord anchorages and strain relief, and protection against hazardous moving parts. In case of doubt, repeat the electric strength test. Results. Remember to enter all test results in the evaluation report, including the test performed, a description of instruments used, their identification or serial number, and their calibration due date. Stability. Safety caution. For very heavy equipment, the stability test may require the use of appropriate harnesses to prevent the EUT from falling over completely. This is acceptable if the arrangement does not interfere with the test. Test setup and procedure. Test sample. A sample consisting of the complete enclosure with any containers containing the amount of substance within their rated capacity and drawers pulled out to simulate the most disadvantaged normal operation condition. Ensure that the surface bearing the EUT is level and that the measuring device is flush with the equipment, leveled, zeroed, and secured to the EUT. Compliance is checked by the following test. The EUT is tilted to an angle of 10 degrees from its normal upright position. A separate test is carried out for all possible sides that may become a hazard when tilted. All casters and jacks, if used in normal operation, are placed in their most unfavorable position, with wheels and the like locked or blocked. However, if the casters are intended only to transport the unit, and if the installation instructions require jacks to be lowered after installation, then the jacks, and not the casters, are used in this test. The jacks are placed in their most unfavorable position consistent with the reasonable stabilizing of the unit. Acceptance criteria. A unit must not overbalance when tilted to an angle of 10 degrees from its normal upright position. Under conditions of normal use, units and equipment must not become physically unstable to the degree that they could become a hazard to operators and service personnel. Results. Remember to enter all test results In the evaluation report, including the test performed, a description of instruments used, their identification or serial number, and their calibration due dates.